Today, we will talk about the low pass filter. We are from Group A. The content that in our presentation is introduction, procedure, results, next, the introduction. Introduction of low pass filter is it divides the spectrum of a signal into frequency component that will be passed and frequency component that will be blocked. Next is low pass filter produce a smoother from signal and producing the short term volatility. The meaning of transfer function is a mathematical description of a frequency domain behavior of a first order low pass filter. Low pass filter exists in many forms including electronic circuit. For example, His filter used in radio. Second one is anti-aliasing filter for conditioning signal prior to analog to digital conversion. The last one is low pass filter produce a smoother form of a signal and reducing the short-term volatility.
How the procedure? By using the NI Multisym software.
Okay, so I will explain about the procedure. First of all, this is some equipment that we need. This is function generator. This is tetronic oscilloscope. This is resistor. This is capacitor, and this is ground. First of all, our resistor we use is 500 ohm, and the capacitance is 1.59 microfarad. Okay, so we close first, and then we start running. Okay, so before that I already take out this channel 1 Vmax, channel 2 Vmax, and channel 1 frequency. As you can see, this is our waveform, and the Vmax output is 1.78 voltage, and this is at the frequency 100. So we need to change to the 200 Hz, and we can see alright, for 200 frequency, the Vmax output, the V output is 1.51 voltage. So after find out the V out max, I show you how to find the graph using Multisym. By press the simulate button, and then you need to go to analyze the simulation. After that, go to axis sweep using the setup, the output as a V2, and then we need to press run. So this is the graph.
So this is the result after we did the experiment. So the frequency that we use is from 100 to 10k, and this is the result. And the magnitude AV is we calculated by ourselves, and this is the graph. Our first graph is magnitude versus frequency. As you can see, the magnitude we get is by the formula V out over V in. And then the second graph is phase degree over frequency. This is a low pass filter type of graph. Right.
For discussion, the important things we have discovered via experiment are that a low pass filter is a filter that passes low frequency signal while blocking a impending high frequency ones. In other words, it is a low pass filter because high frequency signal have a considerably harder time passing through a low frequency signal, do so much more easily and less resistant. The frequency range is which a low pass filter change from low attenuation to large attenuation is indicated by the cutoff frequency of the filter. It is simple to compare the value with a measure when we determine the cutoff frequency. The value of periodic signal are at certain time during a cycle is referred to as the idea of phase. Therefore, when we state the circuit generate phase shift, there is cause the input signal and output signal to be out of phase, which means that the input and output signal not longer begin and end their cycle at the same moment in time. The low pass filter are using RC low pass filter and RL low pass filter with different formula to calculate a FC. In a low pass RC filter, a capacitor is reactive device which offer very high resistance to low frequency or DC signal, and it offer a low resistance to high frequency of signal. As it offer very high resistance to DC signal, in this circuit, it will block DC from entering and pass them off to an alternative part in the circuit. Next one will be a conclusion.
For conclusion, as I mentioned before, an RC low-pass filter is a circuit built from a resistor and a capacitor which only pass low-frequency signal and blocks high-frequency signal. So from the experiment, we know if the value of capacitor is decreasing, the frequency will increasing because the formula of FC is 1/2 pi FC. So we can derive the transfer function of the low-pass filter circuit and its cut-off frequency. Low-pass filter allows frequency lower than the cut-off frequency. Furthermore, the frequency response was also found using both plots, and we will able to compare between accurate and calculate for RC and RL low-pass filter circuit. At frequency well above to cut-off frequency, the capacity reactance of capacitor C is much lower than the resistance of the resistor, causing the output voltage of decrease 20 dB per decade increase in frequency. So that's all for conclusion.